I'm Rajesh Uppal, Director IDST. We bring sharp insights and foresight on defense, security, and emerging tech. Let's dive in.
We are at the edge of a major shift in how cameras work. Traditional cameras only capture pixels, simple dots of light. Computational imaging goes beyond that, treating light as rich information. It can reveal depth, motion, material properties, and even objects hidden from view. This revolution blends advanced optics, signal processing, and AI. Instead of relying on millions of pixels, techniques like single-pixel imaging capture scenes with just one detector. The system projects light patterns, then measures how the light responds. The result is faster imaging that works in low-light and high-speed scenarios. Another breakthrough is non-orthogonal light projection. By projecting patterns onto angled surfaces, these systems can quickly generate precise 3D coordinates. Compact designs mean sensors can be mounted on vehicles, robots, or portable devices without losing accuracy. Cameras are becoming active interpreters of light. Coded apertures encode depth information into images. Structured light maps surfaces by seeing how patterns deform. Time-of-flight sensors measure distances with millimeter precision. AI then decodes these signals, turning noisy light into clear, actionable data. We can now see things that were once invisible. In medicine, this allows virtual biopsies, tracking blood flow without contrast dyes, and spotting tissue changes before symptoms appear. Security systems can identify people across multiple cameras, anticipate suspicious actions from subtle body cues, and detect movement behind walls during search and rescue missions. The hardware behind these systems is equally advanced. Sensors like single-photon avalanche diodes detect even the faintest light. Programmable optics, such as liquid lenses and deformable mirrors, adjust focus and correct distortions in real time. AI accelerators process all this data instantly, often combining visual, thermal, and RF inputs for full situational awareness. On the software side, neural networks reconstruct 3D scenes from limited data. Differentiable rendering helps cameras understand how light travels. Compressed sensing recreates high-quality images from minimal information. Event-based vision only reacts to changes, reducing the computational load. These advances are already changing real-world applications. Autonomous vehicles can track objects in fog or glare, predicting their movements with millimeter precision. Medical imaging can monitor blood cells or analyze tissue at a microscopic level. Security cameras can see hidden or partially obscured objects, improving safety in airports and urban areas. Recent breakthroughs push the limits even further. Twinklewarrow University created a system that tracks fast-moving objects at over 6,600 frames per second, using only 6 bytes of data for each 3D point. MIT developed non-line-of-sight imaging, seeing hidden objects from light reflections with centimeter-level accuracy. Stanford built single-photon 3D systems, capturing details over 10 kilometers, even through fog. NVIDIA and Harvard demonstrated real-time neural holography for 3D displays, and Caltech captured full spectral data at 1,000,000 frames per second. Looking ahead, computational imaging will only get more powerful. Quantum imaging may surpass classical resolution limits. Neuromorphic sensors could mimic biological vision for efficiency. Edge AI will allow cameras to process data directly on the sensor. Ethical frameworks will be essential as these systems become smarter and more capable. The shift from traditional cameras to computational imaging is not just incremental. It is a transformation in how machines see and understand the world. Cameras are becoming intelligent platforms that actively interpret, predict, and interact with their environment. Businesses, researchers, and society will gain unprecedented insights, and those who adopt these technologies will lead the way in the new visual era. The future of imaging has arrived, and it goes beyond the pixel. Thanks for watching. Subscribe, follow, or visit IDSTH.com for more cutting-edge defense and tech insights. See you in the next one.